Hello, I'm Gavin Mendel-Gleason, CTO of Terminus TV. And today I'm going to talk to you about document graphs for the data mesh, how we can leverage connections to create data products. First, what is data mesh? So, data mesh is currently a bit of a buzzword. People have been saying it in various different blogs and throwing it around. So, what is it? Data mesh is a methodology for approaching enterprise data management. It's not a tool and it's not a stack. It's an approach. It's essentially a philosophy of how to build large-scale data integration projects. So, what are the components of the data mesh? One of the major components is the idea of a domain focus. Data mesh has teams who understand the data and how they should develop that data. So data mesh is not just about technologies, it's also about people and how you organize best to produce the best kind of data you can. Now, the creation of domain teams helps to overcome a real problem in enterprise data management. The problem that we currently have with a lot of data management problems is over-centralisation. So you have a big data warehouse team. This team has to collect information from many different sources, and it's information that they are not the experts about. They don't know that much about any of these individual subjects. They're not domain experts. By contrast, the data mesh approach is to take the people who know the most about the data and marry them with the people who can do some of the IT tasks and create a cross-functional group that can be a team to provide the kinds of data that's needed operationally. So, for instance, you might have a sales data product, and that sales data product would be constructed with a combination of people who knew about the domain of sales and IT staff that can support them in producing these data products and turning them into a product. But what is a data product? A data product is commodity data. It's data that is well structured, it's well described, it's easily found, and it's easily consumable. So I have a picture of Campbell's soup, which is a somewhat famous commodity. And this has an example. We have mushroom champignon soup. So this soup is easily consumable. It's made into a single product. Many things went into its construction, but you don't have to know anything about that construction. All of those ingredients are already integrated in an easily consumable fashion. A data product might have many different parts in its construction. It can have all sorts of ingredients. It can have human curated information. It can have information from external sources. It can even have artificial intelligence, which is used to enrich or to create aspects or to give features to this data. The consumer of this data doesn't have to know how the soup is made. It's now soup. They just need to know how to consume it. And that brings us to the next idea, that the data in these data products should be self-service data. That means that it should be easily discoverable, so keeping with an analogy of a grocery store, you can find the aisle in which your data product resides. It means that your services tell you where and what the products are that you have available. Here, you could have APIs, for instance, that will improve the ability to obtain that information and to get the information out as a consumable product. And that brings us to the next concept in data mesh, which is governance. So, not only do you have to have these data products, but you have to have ways that they can be moved about and a clear way of getting and obtaining them. So governance is essentially about laying the foundations for having a distributed system of data management. The data warehouse overcame a very serious problem, which was that we had data silos. And data silos arose because operational data was sometimes enriched or cleaned by a domain team, but it was never surfaced to the rest of the organization. It was kept closed and undiscoverable. Partially, this was because of the difficulty of producing the data in a discoverable format, but partly it's because it was never intended to do that in the first place, and it wasn't given as an operational responsibility of individual teams. Instead, a large central data management team was constructed who was supposed to go out and hassle the various different teams in the organization to bring the information centrally. So you might have HR information or marketing information or finance information, and the central data team would try to amass it all, link across between different aspects, and provide it in a consumable way. However, this leads to serious over-centralization, as I mentioned before. To overcome this, to move beyond either silos or over-centralization, we need to be able to provide the information in a distributed fashion, and that distributed fashion puts a greater onus on understanding how to share the information. So governance is both human and technological in structure. Some of the questions of discoverability, interoperability, and scaling do require humans, but some of it also requires technology, which can make it easier. So TerminusDB is a knowledge graph. At base, we interact with the system by submitting documents. Documents, JSON documents, structured documents that are stored in some dictionary-like format, have become pervasive and are widely used by application developers. The reason for this is simplicity. It's an easy way to model your data, and it's interoperable. You can send it across to different languages. You don't need to know too much about the language that you're communicating with. It's fairly human readable, more readable even than HTML or other XML, other types of formats that were intended to be at least partially human readable and writable. So it's a nice, succinct mechanism, and it's so widely used that most languages have developed native formats for dictionaries that make it very convenient to manipulate data in this fashion. This has driven the incredible popularity of databases such as MongoDB. So you want to make it easy to put data in for application developers. So here you see that Terminus, we have a way of entering in a schema into our graphs, and then ways of entering in various data objects. These data objects are just JSON structured data where the meaning of the data is described by the schema. This is schema first in the way that we do it, and that's really important when you're building knowledge graphs. If you're just using documents, then schema is less important, although I would say in the longer term, for total cost of ownership, schemas are really necessary to keep your database from becoming a soup. However, it's even more important with both collaboration and graph. So, if you want tools that allow you to produce links across things, then you need some way of checking those links. So Terminus gives you some tools to work with that, including the generation of unique identifiers by the use of keys. And these unique identifiers can be referenced internal to a graph or across the organization. Our documents can have links, so they're not just tree-structured information, they're actually graphs. When you refer to a node, a named entity, something that has a unique identifier, the schema tells us that this is not just a string. This is actually an identifier for some other document. And this allows us to build arbitrary graphs from JSON documents. This graph here shows you how you can have links between documents. And if you look closely, you can see that the person, Joe, has a unique identifier, person Joe. He has a friend named person Jill, and person Jill likewise has a backlink to Joe. So they're both friends of each other. It's requited. You can also link to other sub-documents, which means your JSON document structure could be complex tree internally. And each of those subtrees can then link out to external documents. For instance, they might refer to a country from an address subdocument. And that country itself might have complex structure. It might have a name. It may have a perimeter that describes the region in which it resides. Terminus also has a concept of static and dynamic linking. And this allows us to connect nodes inside of a single graph, but also to refer to elements that may not be in our graph at all. And this facilitates the connection of data between data products, so that I might have marketing data that refers to something from finance, and I can use the identifier, describe that it's an external identifier in my schema, and we can have a late binding approach that is similar to dynamic linking in programming languages. So this would enable a late binding approach where you follow the link after you've joined against the data product that you mean to follow it in. So we can build up a huge mass of interlinked data products a bit at a time, where each of these is self-contained, can serve up the information, but you might bring home the soup, you might then bring home some meat from somewhere else, and you mix them together to create some new data product perhaps, or just some analytic insights that you might want for some other operational purpose. So we'll take information from various sources, move it into data products. Those data products can be in Terminus. They could also be in some other element, and we can mix and match them together. We can refer to elements outside of Terminus even, using these unique identifiers. And this idea, which was shamelessly stolen from the semantic web, is a very powerful idea that means that we can have interoperability between very disparate systems, but maintain a strong schema around the kinds of information that we say or purport to know about. So, Terminus also enables other aspects that are recognized as important in the data mesh. And some of these are about data lineage, finding out what happened to data, who did it, and querying information from the past. So TerminusX has versions that allow you to explore the database in the past. It allows you to find the cause of mistakes. It can allow you to find who made the mistake. It can allow you to do various kinds of operations on these. One of them is branches. So we can create branches from any commit in our history, and this enables us to have a very fearless approach to experimentation. This is widely recognized in the programming world, but has not yet become very common in data. We can also time travel, so we can move to these commits. We can even branch from past commits. We could go back into the past. We could find the cause of a problem. We could branch from that commit from before the problem existed, and we could even rebase and move some information from the current world into this fixed universe. That brings us to rebase. So rebase allows us to move features or changes to the data, curation, automatically generated materials, and bring them back into some other branch. Perhaps it's production after we have tested in some other element or some other branch, or it could be some experimentation that was done using machine learning that only later turned out to be a good idea. So document graphs are really about enabling the data mesh and the building of data products within the data mesh. It's not, of course, a data mesh in itself, but it can help you to build a knowledge graph or many knowledge graphs for various different domain-specific data products that you might want to have in your data mesh. Thank you, and I hope you enjoyed that talk on document graphs and the data mesh. I'm Gavin Mendel-Gleason. Talk to you all later.